On today's episode, I have a conversation with Ian Williams. Ian and I are both a part of the Fogbank Audio co-working group here in St. John's. If you would like to learn more about this group, please check out thefogbank.ca. Before Ian got involved with audio, he went to school to become a naval architect. A naval architect is the person behind the scenes who designs everything and anything to do with seafaring vessels. Ian was kind enough to answer my main question, which was, why are portholes round? Among many other questions that sprang up during the course of our conversation. If you would like to check out Ian's podcast, which is called Ships in Port, you can do so on the Fogbank website, which once again is thefogbank.ca. And now, my conversation with Ian. Ian, you're a naval architect by trade.
Yes.
I interviewed a fellow last week who was an architect, like I was just telling you. And I can only assume a naval architect is someone who designs things for belly buttons?
Absolutely. Abdominal design. No, it's anything to do with floating vessels on the sea or water. And it could include submerged vessels with that.
Yeah.
So it's related to ships mainly.
Okay. And how did you get into that?
Well, way back when I was, I think, 14 years old, we had a grade 9 class. The guidance counselor came in and tried to give us some instruction on how to think about what you wanted to do for the rest of your life. And I ran through all the things I enjoyed doing and come up with, I like drawing ships. And that led me to sort of research a couple of paths I could go. I could have been a marine illustrator or a ship designer, which is a naval architect. That's the fancy word for a ship designer. And upon further investigation, I realized that there was only 2 places in the country you could study naval architecture. And there was lots of other places you could do marine illustrating, but both places you could study naval architecture were in St. John's, Newfoundland, my hometown. So that really helped me make that decision. And I ended up opting to go to, at the time, it was the Fisheries College Naval Architecture program right out of high school. So when I was in grade 9, I decided that was what I was going to do. And my high school yearbook says, Naval Architect, future. Right? Yeah. And then I completed the program at the Marine Institute, which was quite an interesting experience. I went from a high school or a grade school environment where showing up and getting a minimum grade was always expected. I went to college and discovered that they expected real work, and they were trying to maintain the reputation of their graduates by making it extremely difficult to get through the program. Some people sort of thought that was unfair, I guess, but the reality is it does high grade the quality of your education that you get. So when you graduate and you have a diploma of naval architecture it's now the Marine Institute rather than the Fisheries College, it means something. And at the time, I just sent out my resume to the various ship design and ship construction entities in the country, and almost every one of them were interested in me because the reputation of the college was so strong. And the companies knew that anyone who got through the program was worth hiring. So it was actually quite a good decision I made when I was 14 years old. I was mostly ignorant of the real implications of what I was doing. I thought I was going to draw ships, and that's all I was going to do.
Yeah.
So that's how I selected that program.
It's such a hard thing when you're in that period of your life and someone expects you to pick a trajectory for the rest of it.
Absolutely. A funny side note on that.
You kind of got lucky in that regard, right?
I completed an aptitude test at the same when I was in grade 9 that the guidance counselor provided, and that came out that I should be a forest ranger.
Ah.
And I reflected on that, and I said, I wasn't thinking of being a forest ranger, and it doesn't seem like something I would enjoy, but that's what the answers came out to be. And I will admit, there's been times over my work career when I was questioning whether I should have been a forest ranger or not. But naval architecture it was, and I did complete the program. And thankfully, the opportunity was right in my hometown, a great program with a really good reputation, fantastic instructors. They really drove us hard, but they were very fair and taught us a lot about how to work. They swamped us with work. We would start probably 7 o'clock on Monday morning. We would do our studies and lab work and work every day till 11 o'clock in the evening. And we would do that 5 days a week, and then we would take the weekends off to rejuvenate, I guess is a positive way of saying it. But we did that effectively for 3 years, 7 to 11, 5 days a week, crunching out work. And we learned a lot, and we worked really hard. And it really prepared us for the work world. To go from the Marine Institute to working in an office was actually a break. So that was very good preparation, and I'm really glad that the instructors drove us that hard and jammed so much knowledge into our heads. It was phenomenal. It was a 3-year program, and we learned a lot.
Okay. Yeah. What's the difference between naval architecture and illustration that you mentioned?
Well, the illustration is the artistic side of it, and you're just dealing with the graphics and the presentation of the image of the ship. But naval architecture, you technically draw the ship, so you draw the design of the vessel, which includes all the correct dimensions. But every single aspect of a ship is touched on by a naval architect. The stability, its machinery, the layouts, the design, the structures, the color of paint that you put in every area. So much like a standard architect on a land base, they cover every facet of the product that they're building. Now, naval architecture brings a little bit. We're always thinking, we're a little bit elitist. We're better than architects because their buildings will float on the sea and encounter the severe environmental conditions that our structures do. So ours has to look good and be functional and be cost effective. Plus, it has to sail the high seas in any weather that it might encounter. And a very important part of naval architecture is protecting the lives of the people who will be operating on that vessel. Even if they make the dumbest mistakes, that ship is there to compensate and to recover from the mistakes and always protect them. Now, that doesn't always work in real life, as we know, but a naval architect tries his best to design into the vessel's, the ability to stay upright and stay floating no matter what happens to it. There's lots of lessons learned. We look back on the history of the Titanic or the Ocean Ranger, and the contributing factors to those disasters are incorporated into the state-of-the-art of the knowledge of naval architects so that they don't repeat the mistakes of history. Yeah.
So when you come out of school, are you ready to build or design anything from a tugboat to a cruise ship, or have you specialized in a certain vessel?
The Marine Institute, or the old Fisheries College, had a flavor towards fishing vessels, but the education is anything that floats, right from a dinghy all the way up to the largest oil tanker that could be built, and anything in between.
So do you, say you're starting, say you get like commissioned or contracted to like design a ship, do you like design every aspect of it and then send that off and it gets built and it's out of your hands, or are you there from the jotting on paper to the final construction where you're walking through and making sure everything is?
We're all the way through.
Yeah.
The practical focus of the technology program was about being employable in any phase of a ship creation process. So right from the concept creation, where you're just sitting down looking at economics, we have to move so many tons per month of this bulk product from this port to that port, and what's the most economical way to do it? Do you do it with one big ship, or do you build 5 little ships? That's just the concepts, right through to like the full design, the layout, the purchasing, the specifications. And then there's the actual construction, the commissioning, and the handover. And actually, on one of the major projects I worked on, which was the Canadian Patrol Frigate program, I started in concept design, and I actually finished after 10 years doing warranty claims on defects in our construction of the vessel. So that was the full cycle.
It's
all
10
the way
years.
through in 10 years.
Wow.
Yes.
So what would be like, I guess it depends on the vessel, but the average what would that whole cycle look like from beginning to end? How long would that typically be?
Well,
10 years is quite a long time, obviously. But
10 years is a long while, but this is a very complex vessel. A naval vessel has so many aspects to it. So the design takes a lot longer. The construction takes a lot longer. And with the way that they don't replace Navy vessels often enough, they probably serve a lot longer than most ships serve too. But again, it's about scale to the vessel. If you can build a fishing vessel, a 45-foot fishing vessel, by the time you think of it to the day it's fishing, it could be within a 1-year period.
okay.
A lot of the time, the major durations come from the procurement and the purchasing of the components. You can have in your head and be able to clearly explain exactly what type of vessel you want, so you can put it on paper fairly quickly, do the calculations for stability and the strength. You could have that done in weeks. It could take you months to build it, really. A 45-foot vessel with, if you had 10 hands working on it, would put it together fairly quickly.
Yeah.
But you just can't have an engine as soon as you want it. And a lot of components in the marine industry are not stock. They may be available on catalog, but when you order it, they start making it in the factory in Germany or wherever you ask for it. So a lot of time you wait for delivery of components, and once those components show up, then you start, continue with the construction.
Yeah. What are some, from like a creative aspect, what are some similarities or characteristics of a vessel that would be like overtly taken from marine life and the shape of marine life?
Well, the first thing is the interface with the sea, the hull form. The ship has to move through the water in a way that it's fuel efficient, so that in its directional flow, when it's transiting, it needs to create this little energy wastage as it's flowing through the water. But then at the same time, a vessel doesn't just transit through the water, it also bobs up and down, it heaves and pitches and rolls, so it needs to be able to go through its range of motion without much interference, so that it's all about energy and cost. You're trying to work out cost effectiveness. I think some of the very early concepts of you see the oldest sketches, they have the picture of the salmon, and they got the belly of the salmon lined up, and then look at the shape of that the ship's hull should be like the shape of a fish. And of course, evolution has figured out that that fish shape is the most efficient shape for that fish, so ships would follow that form also.
Do you watch that show, Mega Ships?
It reminds me of work so much. So, Frontiers of Construction, Mega Ships, I don't really, no.
Yeah,
just
fair enough. The reason why I thought about it was because I watch those shows sometimes, and it's incredible, like the size and the caliber of some of the vessels that are being created. I just wonder how far is too far? Like, do you think we're getting to like maximum capacity on what a ship can be, like in terms of size? And
absolutely not.
No?
I find the ship is I think the perfect expression of the potential for man. I love ships, but I'm intensely aware of what they are. But I don't think a lot of people realize that a lot of ships are virtually floating cities. They're as complex as a city. They can support the life of thousands of people. But they can do something a city can't do. They can transit. They can go from one place to another. And with the vastness of the seas and the lakes that we have and the rivers in this world, to be able to take a large constructed machine and have it to have so much capability. Look at the example of a nuclear aircraft carrier. It's traveling around with 5,000 people living on it. It has an airport on its deck. It has a harbor where it can launch its own vessels. And it has an endless supply of energy. There's not many cities have that. Cities of 5,000 don't have that much, but this ship, it can go anywhere. And it has, the full ability to do that. It has great food. It has great places to sleep. Now, you have to do a nasty job with that vessel. But when that job needs to be done, the ship can do it. So yeah. I find that a lot of technology that's been derived over the centuries has been driven by the demand for ships and what ships are capable of. They've explored new worlds, brought humans to incredible places that they've never been before. Even in this era right now where we may think that spaceships or aircraft are the high-tech components or computers, I think ships were there first.
Yeah.
And ships still have a vital place to play in modern society and will continue in the future. When we look at the energy efficiency of transferring goods around the world, the most cost-effective way to get a product transited around the world is on a ship. And it remains that way, and it will continue that way.
Yeah. I went to the Railway Coastal Museum yesterday for the first time.
Yes.
I had always been confused by the title on the building, like Railway Coastal Museum, because I thought, isn't that just about the railway? And I went in there and learned, oh, like they're so intertwined and they were owned by the same family and stuff. So it was interesting to learn about the railway, but also had the bonus coastal information in there.
I want to point out that the coastal system was the original transit system, and the railway was just an add-on after.
Yeah.
Because the province is an island, and not many of the houses when they were built years ago were road service. They were all serviced by the harbour and the wharf. So those coastal boats were the lifeblood of the province.
Yeah, and it's interesting to think of how, I mean, we have the Trans-Canada now that goes right across kind of the middle, like it arches from coast to coast, but when there were no roads, those boats were like technically the highway around the outside of the province, right?
I'll ask you to do something next time you're out around the bay somewhere. Pay attention to the older homes.
Yeah.
The homes with their front door facing the water were built before the road. The homes that were built after the road had the front doors facing the road.
Ah, okay.
So you'll notice that when you go to a small community now, you'll say, oh yeah, look at that.
I'll keep an eye out for that.
Pre-road, post-road, pre-road.
Yeah.
Right?
Cool. What other, what kind of stuff do you see when you look at a boat that like most people wouldn't see?
Well, I lament the loss of the style. Everything these days is driven by economics. So a straight line is cheaper than a curve. Just think it just makes sense, doesn't it? If you were to take a piece of steel and you were trying to build a ship out of it, if you could build it out of a flat piece of steel, it's going to cost you way less than you had if you took that piece of steel and curved it into the shape of a curved line. So the tight economics and high cost of ships these days have taken the art out of ships. So when I see a ship that has a nice, it's called like the shear line, the main line of the top of the hull is called the shear line. And when I see a nice swooping line with a nice elegant flow to it, I say, yes, look at that, that's beautiful.
Right on.
But then I also look at these very utilitarian vessels that come along and say, that's ugly. I understand economically it's cheaper, but it's ugly.
Yeah.
Right? That's why I'm a big fan of the historical vessels, especially the turn of the century, late industrial revolution vessels, like Edwardian vessels and the Victorian era vessels. Are great monstrosities built, but they have ornamentation and curves and shape that the ship doesn't need, but it just looks good.
Are you familiar with like the history of when motorization kind of took over like the sail era?
Oh, absolutely. It is the Industrial Revolution, and there's a very interesting thing happened with ships, and it was created effectively by Isambard Brunel. Brunel is the father of modern engineering, and Brunel's era, so James Watt invented the steam engine and decided to turn it into a pump that could lift water up out of the mines of the United Kingdom. And that very same era, they started putting these steam engines on top of train engines to create trains. And within years, they were realizing, well, these engines can also turn a paddle wheel at the time. They weren't as keen on the propeller, but they could move great ships. And at the very same time, along with the steam engine, was the realization that if you could make a steam engine, that you needed iron. But with that iron, you could also build steel structures. So the railways were built with the steel. The railway bridges were a big part of the Industrial Revolution, and they were built out of steel. A key thing that Brunel did in that era, he realized that the strength of a bridge could be translated into the strength of a ship. So a traditional wooden hull that was a smaller vessel, you could only build it so big. The trees were only so large, you could only have planks so long, and it could only be so strong. And Brunel realized, right just in the same era of the steam engine, that I can use the structure of a bridge, put a shell all the way around it, and I can build a much larger ship. So ships jumped in size and developed steam engines at the same time. And that happened in about the 1840 to 1860 range. And there was a phenomenal renaissance in shipping at the time. Now, of course, driven by war and military budgets, I suppose. They paid for a lot of it, but at the same time, the flow of people from Europe over to the New World had a big demand for transportation. So a lot of these big ships for transferring people across the Atlantic came to be at the same time. So it was a very exciting era in technology and a very exciting era in shipbuilding and ship design.
I wonder what it would have been like to be in Europe and to get on a boat and come over here and know that it was going to take like 3 weeks or something to get here.
Well, at the time, that was way faster than anything they could imagine.
Yeah, I guess so.
It's all perspective from what they're used to, right?
Yeah.
And another thing must be you grew up on a farm with you've never even seen a train before because you're in the part of the rural part of the world. So you take your donkey down for a few miles and you finally go see a train station. You see a train and you get on this train and it moves you across at breakneck speed like you think you're going to die because the thing is going 30 miles an hour.
Yeah.
And it brings you to a port with a great ocean-going ship there. In this, when these ships were created, these first, like the Great Eastern, the very famous one that brought the transatlantic cable into Heart's Content, that was a monster. And people would see that on the horizon as they were taking the train or walking or taking their carriage into a town. They would see this great monster on the horizon of this ship. And to them, they grew up in a world where a 2 or 3 story building was a big structure. Could you imagine boarding that ship at the time? What it would have been like? And then if you had an opportunity to go down and see where the coal has been fired into the boiler and the great flames shooting out of it and the black smoke, a lot of people must have thought they were monsters.
Yeah, for sure. I would. I look at these like massive cruise ships now and I think, no way, I'm not getting on that. Like it just, I'm looking at it thinking, I get how boats float, but I'm looking at that thinking that doesn't make sense to me.
Well, the idea of Archimedes' principle of why it floats is not that hard to figure out. So the size of the hull pushes away that much water. So the weight of that water is what, as long as the ship is lighter than that weight of that water that's been displaced, it will float. But why does it stay upright?
You tell me.
Right. So the answer to that is physics. Now, that's another big part of naval architecture.
That was always just my answer in the back of my head. I look at it and be like, oh, physics. Okay.
If you don't like physics, you don't want to be a naval architect. Back when I studied it, I came out of high school in 1981, which was just before the era of PCs. So when I went to naval architecture at the Marine Institute, or Fisheries College at the time, I did all my calculations by hand. We were shown how to do everything by hand. Pencil, paper, and that was
Scary.
it. Well, I'm in this modern day of computers, I'm so happy that I did it because
That's all right.
My understanding of the process is very keen. You don't have to trust that the computer did the calculation correctly. I can do the calculation myself by hand to verify it. And it's complex math. But once you know the process, I think GM equals GZ sine theta is the calculation for the writing arm for a ship. So
I believe you.
Right. In the studies that we completed, we derived those formulas that are standard formulas used by naval architects, but they show us right from first principles exactly how the formula is derived. And we go through the physics calculations of the displacement of the mass and the distribution of the center of gravity and where the center of the buoyancy is and how that interrelates with. Now, there's a fancy word in naval architecture called the metacenter. And the metacenter is the location that a ship will pivot about. It's an imaginary point in space, but you can calculate where that imaginary point is. And as long as the metacenter and the center of gravity have a positive number, the ship will stay upright. But in the calculation, when the GM goes negative, the ship will turn upside down. So you have to be able to design a ship, and you use your math to calculate how far over can she heel and still recover.
Yeah.
Right. Most ships, you would have the fright of your life if it actually happened. But most ships float in on the water could heel over all the way to 90 degrees and lay flat on our side and come back up again. And that could be the largest oil tanker that's on this planet can do that. They all can't go to that exact angle, but that's an approximation that ships are very stable. Humans have to do something big time to them, like put a hole in them or burn them, for them to have a problem.
Iceberg.
Right. Or yes, well now, even modern ships should be able to survive an iceberg collision.
Yeah. Due
to lessons learned from the Titanic.
It was a couple years ago. There was that cruise ship in Italy that flopped over. What was going on with that?
Well,
what was that word you used? The meta
center. The meta center.
Meta center. What happened to the meta center on that one?
happened to the meta center on that one is the meta center fell below the center of gravity. Now, you have to set aside the fact that the captain brought that vessel into a location to wave to his friends. Okay, that was the mistake that was made there.
Okay.
Right?
Wow, didn't know that.
But what he ended up doing
was he Italian?
Absolutely.
Okay.
Right. I think he's really proud of himself for some reason. Right. And sadly, people died, so we shouldn't make too much light of it. But the mistake that was made, and there was a shoal, which is a rocky outcrop under the surface. So they were away from the cliff, but there was another ledge under the water that when he took his cruise ship by it tore a great long hole along the underneath of the hull. But what the hole did, it crossed about, I think they might have crossed about 4 or 5 subdivision groups. And that ship is designed to have horizontal sections in it, so that if one section floods, the ship won't sink. I think a cruise ship has a standard that 2 sections can flood, and it still won't sink. But the man opened up 4 or 5 sections, and there's just too much mass, too much water got inside the hull, and when the vessel couldn't overcome it, and it eventually flooded and sank, right?
Yeah.
And landed right on the ledge, of course. Now they were quite fortunate that it did land on the ledge, that helped the people that weren't off at that time, give them some more time to escape. Right? But of course, I think there was a couple. I think it was 2 people died in that one, or it might have been 4 or 5.
I'm not too sure.
Right? Because when you take a cruise ship, you probably got 3,000 or 4,000 people on board. Through that spectrum of 3,000 or 4,000, there's going to be some elderly or some physically handicapped. People are just not going to be able to run up the stairway, get into a lifeboat, and go. And that they became the victims of that. It was a terrible mistake.
Yeah. Why are portholes round?
So water doesn't come in and hit you square in the face. Oldest joke in naval architecture.
I kind of felt like something, I don't know. I just figured I'd had to ask.
There is a technical reason, though.
Oh, okay. I thought that was the official reason.
The technical reason is stresses that build up in metals. If you have a sharp corner, that stress will become very high and will be prone to crack. So you think about it. If you cut a square hole in a steel plate and you bend that plate back and forth, back and forth, back and forth, what's the likelihood a crack is going to form from one of those corners? Really high. And a really bad example of that is when one of the first jet airliners was built by I think the Brits built it, and they put square windows on their jet. And the high level of vibration from the flight, cracks propagated from the corners, and the whole aircraft blew apart in the air, and everybody died. It was a horrible accident. But that literally is the reason why, if you cut a round hole into a steel plate, the stress concentrations have no place to really collect. Right, so it smooths out this, it evens out the stress evenly around the whole opening, rather than letting it concentrate in one place like you would have on a corner.
Yeah.
So if you look closely at ships, you'll see that a lot of places where there'll be a little curve, like when 2 corners meet, there'll be a little curved piece in there to put a radius to the point so that it doesn't concentrate all the stress in that one place.
Kind of like diffuses the stress, like
it diffuses the stress. Yes.
Okay.
Yeah.
Cool. When I'm looking at, Newfoundland has an amazing history with ships and stuff. But when you go to the harbors around, or any outport really, you see the long liners, they're called, like the fishing vessels, and they're so stout. Is that for handling the swell?
The stoutness mainly comes from federal fisheries legislation.
Oh, really?
The fishing zones that the vessels have their licenses to fish in have vessel length limitations. It's an atrocious way to limit the vessel size because it puts fishing vessels at risk. Some of these guys go hundreds of miles out to sea, out in the North Atlantic, deal with very heavy sea conditions, but they're limited in their vessel length. And when the length is limited, you've got nowhere to go but sideways and up. So that's what you see, these quite short vessels. They're very broad and very tall.
Why do they impose the length limitation?
It's an ill-applied attempt to limit how much fish they can catch.
Oh, wow.
So really, if you put a ship out there that's 1,000 feet long, it would basically take everything out of the sea and fill its hold with it. So they say, well, we'll just make the small boats. They can only take so much fish at a time.
Yeah.
It's a good idea. As a naval architect, I'd prefer that they limited the size of the hold. The dimensions of the volume of the hold should be the restriction, and let a fisherman put any safe vessel that he wants around that restricted dimension hold. Because that is the intent of the legislation, is to how much fish they can catch.
How old is that legislation?
I don't know exactly what year it was brought in, but that's the way it's been in Newfoundland for quite a long while, right?
That's so strange, because you think any sort of legislation that compromised their safety would be reformed as soon as it was realized, you know?
Yes, but this is decided by governments. You know better than that.
Yeah.
Right?
Yeah. I'm always curious when I travel different places, whether it be in the States, Canada, or abroad, the different ways boats look in those places. And I always wonder, and I wonder this about buildings as well, do the structures influence the culture, or does the culture influence the structures? So an example that we could work off of is like smaller fishing vessels in St. Pierre seem more longer, and like they have pointier bows and sterns. What could
cultural style affects vessels.
Yeah.
You certainly will. Some aspects, the French legislation for their fishing vessels is not the same as Canadian legislation for their fishing vessels. So one of the factors, as I mentioned, the short, stout, stubby Newfoundland fishing vessel, you may not see in a French vessel. She may be longer and sleeker because their legislation is different. But that being said, yes, there are different styles, and you'll find it even if you go around the island and you look at the vessels that are around. People from different parts of the province have a different approach and different way that they like to build their boats.
Yeah.
You can go to Greece and their fishing vessels they'll have certain colors painted on them. You can go to Indonesia, they'll have another style of boat, but that all comes from the local shipbuilding history and what they're used to doing in those areas.
That's kind of interesting, because that sort of means that, I mean, if legislation's influencing the kind of, like, the restrictions on how a vessel can be built, then I guess the legislation is kind of informed by the culture. Because if we're thinking about here and the restriction on the length of the fishing vessels, that kind of shows you that the government has less of a emphasis on safety.
Well, I'm sure every single individual with the organizations who deal with the fishing vessels and part of the fisheries departments provincially and federally, they would all put safety as their first concern. But to change legislation is no easy task. It takes a concerted effort over years, and it's just not easy to change rules.
That's right. That goes for anything, really.
It goes for anything.
Yeah.
Yes.
Do you have like a favorite type of boat from a favorite culture?
A favorite type of boat?
Or place in the world, geographically?
My favorite type of vessels are, as I mentioned earlier, Edwardian heavy battleships.
Okay.
I'm fascinated by the Industrial Revolution, and one of the products of the Industrial Revolution were these heavy naval vessels, and I just like them for some reason.
Yeah. Fair enough. When it comes to colors on boats, are there any like taboo colors, or specific design choices or things that are avoided? Because I think
there is some, and none of it makes any sense.
Okay.
Right? I'll go back to, it's bad luck to have a woman on your vessel.
Yeah.
Right? That makes no sense.
Not really.
Most commercial vessels these days, they're indifferent to it. They're modern. It doesn't mean anything to them. But some fishermen still don't like a woman on their boat. And it's not because they're against women. That's the tradition that they were taught from their father and their grandfather. So along with that, feminine colors. If you painted your boat pink, somebody's going to look and say, why did you do that? Now, there's absolutely nothing wrong with it. And I hope there's lots of female skippers and fishers out there, and they can have the pinkest boats in the world. Like, it makes no difference. But that's more male chauvinism than it is a tradition with the sea. But I've also encountered, and again, this one makes no sense to me, there's bad luck to have a green boat.
Really?
I don't know why. Right? It's also bad luck to have a green NASCAR too, but where that comes from, I don't know. Right? And I bet you if you went around the world, you would probably find someone who said blue was bad luck, and another fellow would say, oh, black is bad luck. Right?
Well, it's funny they don't use feminine colors, but most of the times they have feminine names.
Well, ships are she's for the most part.
Why is
until
that?
you get to a tugboat, and then they're he's. Explain that one to me. I don't know.
Yeah.
Right? Yeah. I don't know why it is, but that's, there's the old lure of the sea. I'm married to the sea. I'm married to my boat, and all this kind of stuff. But traditionally, they're she's, and they typically have female names.
Yes.
Yeah.
I guess in any occupation involving open water is so risky that any superstition is closely adhered to.
Well, before engineering was realized and a scientific method was applied to the design and construction, everything was tradition. Everything. What worked before will work again. If you're not doing math and you're not doing the physics, if you do something different, you're taking your life in your hands. So people tended to stick to their tradition. So even if the tradition was green boats are unlucky, well, that's the tradition. Somebody must have died in a green boat, and I'm not going to take that chance.
Yeah.
So, but it only makes sense when you think about it, because ships, the Industrial Revolution, 1840, 1830, that started to come in. Before that, for the hundreds of years that ships were developed, it was all based on what worked before. And what worked before is another way of saying tradition. Right?
It almost seems like places where the sea is such a key component of life are also places of extreme tradition. You take Newfoundland, for example. I mean, a lot of people here are like steadfast on their traditions. Like they don't, even when it comes to, I'll use my dad as an example. When it comes to trying new foods, my dad is not trying any new food because it's just too, he's like, I'm eating this, I'm only eating this. That's just a minor example of the tradition in Newfoundland as a whole.
That's true, but I think that I'd put that down to we don't have a lot of cross-trading of people here. The few that came to Newfoundland stayed, and people, we're not a crossroads of any place anymore. Right? Or I don't think we ever were a crossroads. We don't have transients come and go to give us influence from all these different cultures, and just the idea that it's okay to be different. We're pretty white bread here, right? The families that lived in a certain cove 300 years ago have descendants in that cove right now, and it's pretty much the same makeup of families from across hundreds of years.
Yeah.
And I think that's a big part of why change seems to be a lot of change around here, because it's so bold. Because we're not a Montreal, or we're not a New York or a Rotterdam, where there's people crisscrossing from every part of the world on a regular basis.
Yeah, the family thing. I noticed whenever I read any Newfoundland history, even if like from 100, 200 years ago, I'll be like, oh, a Whitty, I know a Whitty. Oh, a Reed, I know a Reed. Like,
Absolutely.
It's crazy.
Yeah.
The whole, I still wonder that about like nautical places, whether they're more steeped in hard, fast traditions than any other place. But I guess, I don't know, it depends on the culture.
You imagine a rural area in Central Asia somewhere where for centuries they've been growing the same product and they've lived in the same villages. I suspect that they'd have very strong traditions, much like our marine traditions.
Yeah. I think I might need to develop that thought a little bit more. I'm interested in this idea of a meta center. Like that could be a metaphor for a lot of stuff, I think.
Oh, absolutely. It's the meta center is the hard to define, always changing, critical piece of information that you need for a ship. And it's what makes ship stability calculations tough. Is the fact that like the center of gravity of the vessel is relatively an easy concept to figure out. You just figure out where all the weights of all the objects are. You cumulatively add it up and divide it back by the total. It tells you there's where the center of gravity of this object is. And the center of buoyancy, which is another key component in stability calculations, is just the center of the volume of the hull that's in the water, is the center of buoyancy. Now, the weird shape of the ship hulls makes it a little complex to calculate where that location is, but it's not that difficult. It is a place in the ship. The metacenter depends on how far you've leaned over, how much the wind is blowing, how much liquid is flowing around inside the tanks of the ship. There's a lot of variables that affect the metacenter, and the metacenter actually really on a vessel on the water is dancing all over the place. So be able to do the math to calculate where that dance is going and make sure that the dance never goes outside the line.
Yeah.
Right? There's a certain line that if it goes out past there, you ain't coming back. You're going upside down, and that's the end of the vessel.
I'm picturing like two sumo wrestlers, and one gets pushed outside of the circle, and then it's over.
Yeah, something like that. Yeah.
How does the metacenter change in like a catamaran or like a multi-hull vessel? Are there one per hull, or is it in the middle somewhere?
Well, there's, from the point of view of the vessel, there's only one vessel. As long as it's all joined together and it works as one structure, even though there's two hulls, there will be only one center of gravity, one center of buoyancy, and one metacenter for the entire vessel. But the likelihood of tipping over and capsizing in a twin hull vessel is vastly decreased because the breadth of the vessel makes it much more difficult to tip that way.
Why aren't they, if the likelihood of them tipping is diminished in a catamaran or something like that, why aren't they more popular? Is it
the structural difficulty? If you have two independent hulls floating on the water and you want to join them together, it's the stresses that are on that joint where the cross beam joins to the hull is intense. So you say, okay, why wouldn't you make a cruise ship with two hulls like that? Well, the cruise ship is so massive, and the amount of stress that would be concentrated on that connection will be phenomenal. It'd be very difficult technically to do. So typically catamarans are going to be a smaller vessel where the materials that are available to us can be built to survive that stress concentration.
So if there was like a graph of like catamaran like versus size, there would be a point it got to where like the size didn't make it worth it for it to be a catamaran?
Yes, exactly. That's what would happen. Now there are some very large ships that are catamarans, but built very specially, and the price goes up. I think the largest catamaran hull ship I can think of is a sea-going rocket launching vessel that basically was two ships and they joined it together, right? With a bridge structure, but that structure is massive.
Yeah, I'd say you'd need some stabilization if you were blasting rockets off the deck.
Yeah.
Crazy. Oh man. The St. John's Harbor has like the narrows that a boat would come in through obviously is it can only fit a certain size ship in here.
Right.
Do you know like the largest ship that's been in here? Or?
I don't recall the name of the large. I remember one of the largest. Back in the early 80s, there was a ship named the Hope Clipper, and she suffered some bow damage off the coast of Newfoundland somewhere, and she needed to make port in the nearest port. She was virtually empty and was floating very high in the water. If she had been loaded with her cargo, she wouldn't have come through the Narrows. But because she needed to come in for an emergency repair, and she was floating very high because she was empty, she was able to sneak in through. Now, she came in through pre the blasting of the Narrows. I forget which year they did that.
I didn't know they were blasted.
They blasted out the Narrows to improve a little bit of and it was actually the depth. It wasn't the width, it was the depth of